When Tears of the Kingdom first came out, there was a ton of speculation regarding how much time passed between this game and Breath of the Wild. I can make one statement for certain, and it's that Tears of the Kingdom takes place several years after Breath of the Wild. No, not because Riju and Tulin aged, or because Madison exists now, but because the climate of this version of Hyrule is extremely similar to what it was in Breath of the Wild. Whoa, back up. What do we mean that the climate is similar between these two games? Of course it is! It's the same Hyrule! We know that it hasn't been that much time that's passed, given the ages of everybody. Why would the climate be any different? Well, let's break it down a little bit. Many factors can naturally change the climate of a planet. Most of these natural factors take far too long to change though, so the climate wouldn't be impacted when there's such a short time difference between the events of these two games. For example, the Milankovitch cycle takes literal thousands of years before it changes in a significant way, so the climate wouldn't be impacted based on that or various other sources. However, there is one factor that should have impacted Hyrule's climate but seemingly doesn't. Death Mountain. As we're told in Breath of the Wild, Death Mountain has erupted at least a couple of times right before Link has to stop Calamity Ganon. We also see evidence of this as lava is actively flowing around the mountain, which indicates this has erupted at least somewhat recently. Based on this, we can infer that Death Mountain has erupted somewhat recently in Breath of the Wild. Granted, we had a divine beast running around that was possessed by the malice of Calamity Ganon, so it's possible that this was the cause of things happening, but nonetheless, it happened at all, so we gotta talk about it. Assuming there was an eruption, the climate is going to change at least a little bit. How? Don't worry, I'm gonna tell you. Buckle up, we're in for a journey. When a volcano erupts, it releases various gases, aerosols, and ash into the atmosphere, usually up into the stratosphere, the second layer of the atmosphere, if you will. While some of it will quickly filter out over the days or weeks, like the volcanic ash, some of what is released remains in the atmosphere for an extended period of time. Namely, we're talking about two gases I've talked about a little bit before on this channel: sulfur dioxide and carbon dioxide. Let's start with the more well-known of the two, or at least what I assume is the more well-known of the two: carbon dioxide. Carbon dioxide, as you may already know, is a greenhouse gas. We know it to be one of the gases responsible for climate change, namely the reason for warming temperatures we've seen across the entirety of Earth over the last century or so. Okay, that sounds about right. So we'd expect temperatures to warm in this area after a volcanic eruption, right? You'd think that'd be true, but it's not quite so simple. The United States Geological Survey estimates that the global emissions of carbon dioxide from volcanoes is 0.26 billion metric tons per year. Okay, whoa, I threw the number billion out there, so that probably sounds like a lot, and to be fair, it is. But let's compare it to the carbon dioxide created from anthropogenic fuel combustion in 2015. In 2015, the USGS reported that 32.3 billion metric tons of carbon dioxide were emitted. That's quite a bit higher than 0.26, not going to lie to you there. On top of that, we've studied various volcanic eruptions over the years. In every case studied, carbon dioxide released in volcanic eruptions has never caused detectable warming of atmospheric temperatures, especially not compared to what we as humans have been emitting into the atmosphere over the last several years. Safe to say, I don't think carbon dioxide is what's impacting the climate after a volcanic eruption. I guess that's good news for our friends in Hyrule. They already have enough problems with Ganondorf terrorizing them not once, not twice, not even thrice, but 4 times in this era of Hyrule! She's a menace. First with the imprisoning war, second time with the first calamity, third time with the second calamity, and the 4th time with his return as the Demon King. Talk about a villain that just won't back down! I gotta give this version of Ganondorf some serious credit, dude is persistent. Anyway, sorry, he's a great villain, love him to death, well, love to hate him, it's a whole thing. I'm not sure I buy the whole hot Ganondorf thing, but that's a whole different scenario. Let's get back on track. At least Hyrule won't be experiencing any warming of the temperatures with a volcanic eruption. Yet, what happens when that sulfur dioxide is released into the atmosphere from a volcano? Well, I do have news for you. We have a real-world example. This time, I'm taking us back to 1815. No, I'm not kidding. So what happened in 1815? Well, Mount Tambora erupted. That's what happened. Located in modern-day Indonesia, this eruption was the largest in nearly 1,300 years and was very powerful. Evidence suggests that this had a volcanic explosivity index value of 7 out of 8 on the scale. This eruption was not only insanely powerful, but it also released a lot of sulfur dioxide and ash into the atmosphere. When this happened, this resulted in the partial blockage of the sunlight and affected weather patterns all across the globe for the following year. Now, this alone was enough to rock the climate, but there were also other eruptions that were categorized as level 4 or greater that happened in the years preceding this one in 1815. There was one in 1808, two in 1812, one in 1813, and one in 1814. Keep in mind that anything that's a level 4 eruption or greater is considered to be a powerful eruption. It's possible that these exacerbated the situation caused by the level 7 explosion of Mount Tambora in 1815. The effects of this would become apparent in the following year, 1816. So the first thing that happened was, well, the sun's light got blocked out partially. I think you could probably guess what happens when the sun's light is blocked a bit. If you've ever experienced a solar eclipse, you may have noticed that the temperature tends to drop at least a little bit, by a degree or two. The less light coming into Earth from the sun, the less radiation we have that's able to warm the planet. This resulted in temperatures dropping globally. This was bad enough, but the sulfur dioxide resulted in a dry fog over the United States in particular, which caused cold and frost, even within the summer months. This has led to us calling 1816 the year without a summer. This year was devastating for many families. In 1816, there were various crop shortages across the United States and Europe, leading to famine and severe economic distress. If you're wondering, wait, economic distress? Remember, a greater percentage of the population were farmers back in that time. It's kinda hard to sell crops if you can't grow any to sell. It was a really rough year for many. While 1817 was a bit better, it was still cooler than average throughout the year. This also partially contributed to the westward expansion that the United States saw during these years. Okay, so that's how 1816 shook out for the world, but what does that have to do with Death Mountain's eruption? Well, sulfur dioxide tends to cool the atmosphere. It doesn't warm it. While ash is quick to filter out of the stratosphere, sulfur dioxide, not so much. It can live in the stratosphere for anywhere from 6 months to 3 years. On average, it lives there for about a year and a half, 2 years. During that time period, the climate is bound to be a bit cooler. Now, assuming this is not a supervolcano, which is an entirely different breed of volcanoes I'm not going to get into here, a volcanic eruption won't necessarily result in an ice age or anything like that. Temperatures should generally be cooler, though. So, given eruptions from Death Mountain, shouldn't we see cooler temperatures from it? Well, yeah, we should. The Death Mountain area of Hyrule, and possibly the rest of the land, likely did. If I had to guess, the temperatures were likely reduced for a period of time. It's possible that some areas of Hyrule received more precipitation as well due to increased particles in the atmosphere for water vapor to cling onto, which results in atmospheric saturation occurring more often, meaning greater rain showers. I'll go into that more detail in the future, I promise. It also may have been generally colder as well. That's likely how Death Mountain's explosion impacts the climate in Breath of the Wild. Yet note we don't see this in Tears of the Kingdom. The climate seems to be exactly the same as when we left it. Why does this happen? Well, I do have a thought. If I had to guess, given that a volcanic eruption only disrupts climate for a mere couple of years, I think that at least 5 to 7 years have passed since the events of Breath of the Wild. The climate in both games is extremely similar. The really big difference we see is that Death Mountain isn't exploding as much. It's a lot more dormant in Tears of the Kingdom than it was in Breath of the Wild. This may also be due to a lack of a divine beast running amok due to Calamity Ganon's malice. Let's just say that the divine beast caused some chaos when Ganon was in control. If it had been a shorter amount of time between these two games, I think we would see a lot more rain than we do, and not to mention Link would probably need that cold gear in more places than just Hebra and other snow-covered regions. Or if he's wandering the desert at night, it does get cold there too. We'll talk about that another time though. Thank you all so much for watching. If you enjoyed this video and want to see more content like this, be sure to subscribe. I have more coming. I appreciate you all. Have a good rest of your day.